Exciting. All right. So for number 10, you got x cubed plus 2x minus 9 equals 0. And they want you to list all the possible rational roots. So actually, I'm going to start with 14 because this will be more representative. So it turns out you don't care what any of the middle stuff is. All you care about are the first and the last. And so your possible rational roots are going to be factors of this last term, so like 1, 2, and 4, over factors of that first term, so 1 and 3. So any combination that I can make. So if 1 is the denominator, I'd have 1, 2, or 4. And if 3 is the denominator, I'd have 1/3, 2/3, or 4/3. And I could have plus or minus any one of those. And those are my potential rational roots. So it's kind of neat. Like you go from having no idea what the roots of this equation would be into like, well, if they're rational, they'd have to be one of those. So how did that seem? I can do another one just like that if you want. Yeah. So if I did, let's try like number 13. They have 5x cubed minus 6x squared minus 9x plus 2. So all we care about, the factors of 2 are 1 and 2. The factors of 5 are 1 and 5. So we're going to make all the possible combinations. If 1 is the denominator, I'd have 1 or 2. If 5 were the denominator, I'd have 1/5 or 2/5. And plus or minus for all of those.
Okay.
And that's it.
That's it?
That's it. So right now, that's just, if they just say list all possible rational roots, that's what you do. And later on, we'll use these. But right now, that's as good as that gets. Sometimes there are more, sometimes they like simplify. You don't ever have to repeat one if there's like, if you got like 2/6 and later on you got 1/3, you don't have to list it twice. Just reduce it.
Okay.
Yeah. So that's all that. I kind of want to use that to jump down. Book is stupid. Okay, even though he didn't assign 33 through 38, it's going to come back up in, you'll need it for 5, 6 also. So we preview it here because you're going to need it there. Because the whole reason we list out these possible rational roots is because we want to test them to see if they really are roots.
Yeah.
So let's take a look at number 34. And they actually want us to find them, like figure out if they actually work. 39x minus 15. So now, before we did this, you've never learned to factor anything this big. You've never learned to do anything with 5 terms. You're like, whoa, that's crazy. But now you know how to start guessing. So you could list out the possible rational roots just to get more practice. So factors of 15 are 1, 3, 5, and 15. And factors of 6 are 1, 2, 3, and 6. So if 1 were the denominator, you'd have 1, 3, 5, and 15. If 2 were the denominator, 1/2, 3/2, 5/2, 15 halves. If 3 were the denominator, 1/3, 3/3 is 1, so I don't have to list that again. 5/3, and 15/3 is 3, so we don't have to list that. Almost there, I promise. 1/6, 3/6 is 1/2, 5/6, 15/6 is we've already listed. Plus or minus, all those. I usually don't bother to write them if he doesn't ask for them, but just for the first one, now we're going to start testing them. And we're going to test them with synthetic division to be faster. Like you could just plug in the one, right? Because we are looking for like, does this... Oh
but you
God.
have to plug in for every...
Yeah, well, it just, we learned, and you could plug that in and see if it works.
Yeah.
But we learned a faster way with our remainder theorem. We learned that if we just did a synthetic division, we could figure out what we would get when we plug in each one of these. So I'm going to plug in the 1, and we do, and then this is, and what we're looking for is if it's a root, it would equal 0, right? So it doesn't equal 0, so 1 is not a root. So we try again, and usually I try 1 and then I try the negative 1. This does not seem like it's working, right? No, too big, not going to give me a 0 there. So then the next one I'm going to try, I'm not going to bother to try a 2 because that's not in my list. I'm going to try a 3. And hopefully the book will throw us a bone. And hopefully this will work. 6. They kind of keep getting bigger, don't they? 28 times 3. I don't think that's going to work. Oh my God. Maybe this is why he didn't assign these. Normally, I can tell you that normally the 1 or the negative 1 will work. Normally, you don't have to try too far. Holy crap. What is wrong with this thing? And it gets really big. I don't feel like maybe the 1/3. I'm going to try the 1/3. If that doesn't work, I'm going to use Desmos.
Okay.
1/3, because I can tell you that normally they're not so painstaking. Okay, so hold up. We're going to use Desmos. Let's see what we got. Make sure I wrote the problem right. 4.
Yeah.
6. All right. So it was 2.5 and negative 1/3. No, 2.5 is there. That's that 5 halves there. And then the negative 1/3 is also there, plus or minus, right?
That would take so long.
I know. Your book is terrible. It's not, he's not going to do that. So if I had just had a little bit more patience and done a negative 1/3, let's do that. So here we go. We got negative 2, negative 15. 1/3 of 15 is 5. 1/3 of 18 is 6. Negative 45, and 1/3 of that is 15. And look, we got a 0. Yay! Holy crap. All right. So what the beauty of this synthetic division is that not only did we find a root, but we whittled down the equation. If you divided it, you'd have a 6x squared minus 15x plus 8x cubed squared 18x minus 45. This power is always 1 less than what you started with. Mm-hmm. And in the beginning, we started with an x to the 4th. And that last one will be the remainder. So cool. So once you've whittled it down into what they call a depressed polynomial, it's a little depressed polynomial. It's so sad. Maybe this factors, because now you have 4 terms. So maybe it factors by grouping. It's worth a shot to check. 4 terms factor by grouping. I could take a 3x squared out of here, and I could take a 3 out of here. I can take more out of there. Or I can take a 9 out of there. I can divide 9x, 2x minus 5. Hey, look, it groups. It groups. So then you can do 3x squared plus 9 times 2x minus 5. And you can set the 3x squared plus 9 equal to 0 and the 2x minus 5 equal to 0. And you can get that 5 halves, right, that Desmos said, right? Mm-hmm. And then the other ones that Desmos didn't show were these imaginaries, because you got the square root of a negative, so plus or minus I root 3. So that is the gist. All your zeros are negative 1/3, 5 halves, positive I root 3, and negative I root 3. And in 5.5, they're going to make a big, or 5.6, they're going to make a big deal that if we started with an even like a 4th degree polynomial, you're going to end up with 4 roots. And some of them may be imaginary and some of them might repeat, but that is the gist. And you can use, if you can't factor it right away, you use your rational root theorem to try to break it open and then keep going from there.
Okay.
And that is the gist. And it wasn't supposed to be so messy, but yeah. But that's going to cover both 5.3 and 5.6.
Okay.
Wow. So I'm not going to do another one from that section because that was a pain in the butt. Mm-hmm. But I can do one from 5.6 because those are probably rigged to work a little bit better. So we can do find all the roots. So some of them, like 9, you can factor already. So 5.6, just factor by grouping.
Okay.
So always go back to like your regular factoring if you can do it. But when you get to like number 10, you've got x cubed plus 4x squared plus x minus 6. If you were to try to group this, these don't match. So before we had this section, we were lost, but now we're found. So we're going to start trying to guess rational roots. And I would list them, except on all of our lists, you'll notice that 1 is a possibility. So I always try that first. Mm-hmm. So I'm going to try the 1, put it in, and hey, it worked. Because this chapter is a lot nicer. Mm-hmm. So not only did we find 1, we whittled this 3rd degree polynomial down to a 2nd degree polynomial. And once you get to that, it's either going to factor or do quadratic formula. You can stop guessing, right? Stop guessing once you get to an x squared. So this one does factor. So you've got -2 and -3. And so when you list them all, you've got -2, -3, and 1. It's so fun, right? It's okay. Yeah, they will not make you guess forever, I promise. Okay. So if we did a slightly longer one, am I killing you? Are you okay?
I'm okay.
All right. Did you want a break to try any, or is this okay? Am I just walking you through?
No, this is good.
Okay. All right. So this one, we have 5 terms, so we wouldn't know how to factor that because the most we can do is 4. So we're going to start guessing. Always start guessing with a 1. Unless you have, I don't know. But, so we just do your normal synthetic. And you get a -2, which is not 0, so we try again. Don't be too scared. I think something's going to work. Okay, we try again. So 2 is a possibility because 2 is a factor of 12, right?
Mm-hmm.
So I'm going to try a 2. Phew. There we go. Got one. Not only did we get one, we whittled this down from a 4th degree to a 3rd degree. Because now it has 4 terms, I can attempt to group it. And now, yeah, it groups. See it?
Mm-hmm.
If it didn't group, you would start your guessing again with that polynomial.
Okay.
Okay?
Mm-hmm.
But if it groups, use it, right? So if we want to know where this is 0, we would set each one equal to 0. So this one's just giving us the x equals 2, but this one's giving us plus or minus √3. So all of our zeros are the 2, the plus √3, the minus √3, and the 2. We have 4 roots for our 4th degree polynomial. All is well with the world. That's what this is all about. Let's see, what else did he do? Oh, 560 gives a worksheet he doesn't actually do. A couple things to notice is that your irrational zeros come in pairs. So the fact that √3 and minus √3 were both roots, that's always going to happen.
Mm-hmm.
So both radical and complex roots, they come in what they call conjugate pairs. So if they were to tell you that 5 plus 3i is a root,
Mm-hmm.
then you would know for sure that 5 minus 3i is a root. And if they were to tell you that 2 plus √5 is a root, then you would know for sure that 2 minus √5 is a root. Same thing, if you knew that 3i was a root, you would know that -3i was a root. So, and this is, I should say, if your polynomial has real coefficients, which all of the ones that we do in this class do. So yeah. Every time I do the videos, I think I go a little faster than usual. So I'm like, So now and then I'm like, oh, we finished with 5 minutes to spare. So anything else that you want to see an example of on video?
I don't know. Because I know we're doing 5-5 on Thursday.
Okay.
And
so,
then
yeah.
I guess we'll do 5-6 on Monday.
Perfect. So now you should be ahead with what we did here.
Yeah.
And I skipped over just a little bit of 5-5, but I think I made up for it here.
Yeah.
Like this was part of 5-5.
Mm-hmm.
So if I go back and they say 5.5, if they tell you your roots are, so just the worst one they could possibly give you would be something like 4, 16, 1 plus 19i. And they want you to write an equation given those roots. And so we know that if 4 is a root, then x minus 4 is a factor. We know if 16 is a root, then x minus 16 is a factor. If we know that that's a root, then we know 1 minus that is a factor. And if we know that this is a root, even though they didn't tell us, we know that's a root too. So we have to do that one as well. And this is in factored form, but they usually ask for standard form. So then you'd have to multiply this whole crappy thing out. It's not too bad. Like this guy, you could just do 16x minus 4x. So that's that one. And then this one, it's x minus 1 minus 19i when you distribute, and x minus 1 plus 19i. When you finish, all of the i's are going to go away. I kind of like doing these in a box. I normally don't like boxes, but I kind of dig them for these. Have you ever done a box? Where you write like this guy going down there and this guy going across there?
Not with this.
Yeah, so you can do it with, and then you just kind of multiply. So x times x, x times negative x, and then you're just multiplying. Oh my god, 19 squared, whatever that is, right? Holy crap, that's big. You seeing where those are coming from?
Mm-hmm.
Cool.
Yeah.
And so now you'll notice that the negative 19xi and the 19xi cancel, the 19i and the negative 19i cancel, and then I squared is negative 1. So this is just going to be positive 19 squared.
Okay.
And 19 squared is 361. And so if I add 361 plus that 1, I get 362. And then my other survivors are the x squared minus 2x.
Okay.
And then you just have to do this times that, which you can do in a box or you can do like normal, but now you've taken care of your eyes. Any questions on that before I turn it off?
I don't think so.
Okay. So we'll